Hello and welcome. I'm Dr. Pauline Fu. In this video, I will present least squares regression. At the end of this session, you will be able to find the least squares regression line and use the line to make prediction. Interpret the slope and y-intercept of least squares regression line. Compute the sum of squared residues. I'm going to use an example to explain related concepts and techniques. This example asks you to find the equation that describes the linear relationship between x and y. So, question 1, find a linear equation that relates x. Remember, x is also called explanatory variable. And y also called response variable, okay? So response variable is the y, vertical axis, explanatory variable, horizontal axis. So found linear equation. Remember from high school, in order to find an equation, you have different methods. One of the methods is to find the slope. And also to find a point in the data set, x1, y1. So for convenience, we select a point, for example, 2 and 5.7. This is the point we select. And another point we select is 6 and 1.9. So we have 2 points, okay? If you have 2 points, you can calculate the slope, okay? Slope equal to y2, 1.9 minus y1, or y1 minus y2, doesn't matter, okay? So let's say y1 minus y2 divided by x1 minus x2. So I'm going to label here. This is x1, 2. y1 is 5.7. x2 is 6. y2, 1.9. Okay, so slope equal to y1 minus y2, y1 minus y2, divided by x1 minus x2, and you get negative 0.95. Okay, so that is the slope. And once you have the slope, the equation is y minus y1 equal to slope times x minus x1. So y1, 5.7, x1 is 2. Slope we have just calculated. And you do a little bit algebra, and you come up with this linear equation. Y equal to negative 0.95, x plus 7.6. Okay, so this is a linear equation. If you ask, can I select 2 different points? For example, can I select maybe this point and this point? Of course, you can select any 2 points, okay? But do you get the same equation when you select different points? You get different equations when you select different points, okay? I will explain the reason in a few moments. Okay. This is the question 1, found the linear equation. And question 2, graph the equation on the scatter diagram. Okay. Graph the equation. You can use paper and pen to graph the equation. Here, I'm going to use Excel. Okay. So where is the data set? Okay, this is the data set. I'm going to erase my annotation so that you have a clean data. Okay, this is the data set. What is the question here? Question B asks you, graph the equation on the scatter diagram. So we have to create a scatter diagram first, then write down equation on the scatter diagram. Where is the number? Okay. This is the data, okay? I just transpose. I turn original data 90 degrees so that I can conveniently use the Excel scatter plot. So select X and Y as well as the data set. Click Insert. And then scatter plot. Scatter plot. Now you have this scatter plot. Okay. And you created scatter plot. Next, write down an equation, linear equation on this scatter plot. Okay. Once you have this scatter plot, you click Add Chart Element on the top left corner here. And then select Trend Line. Then click Linear. See, you have this equation. Okay. And what this line, you have the straight line. Where is the equation? You double click this line and you have format trend line dialog box. Toward the end, you have display equation on chart. See, you have equation here. I select display equation on chart. Okay. And you can make this equation bigger. Okay, I'm just going to move the position. And then I'll try to make the font bigger. Okay. So I'll highlight the text, click Home, and increase font size. Okay, so this is the equation, y equal to 0.713x plus 6.55. Okay. As you can see, this equation is different from this one here. We get y equal to negative 0.95x plus 7.6. By the way, there is a negative here, okay? There is a negative, slope is the negative here. Okay. So we finished the question B, graph the equation. Graph the equation on the scatter diagram. Okay, on the scatter diagram. So maybe I just want to copy this one because this one has the equation, Control C and Control V. Okay, so this is my Excel result. Excel result over here. Okay. Question C. Use the equation to predict y when x equal to 3. When x equal to 3. there are different equations here. One equation is here, y equal to negative 0.713x plus 6.55. The other equation is here. And which equation you are going to use? You can use either of them. So let's say use the first one, y equal to negative 0.95x plus 7.6. And when x equal to 3, you plug in x with 3, and you get the result for y, 4.75. So this is the prediction by using the first equation. You can also do the prediction, use the second equation here, use this equation. Guess what? You are going to get different prediction value because you are using different equation. Okay. And then there comes a question. When I use different equation, I get different prediction. Which one is better? Which prediction is better? That is the topics we are going to turn to. And we are going to introduce least square regression line. When you use least square regression line, that prediction is the best because it produces the minimum errors. Okay. So first, we'll introduce what is the residue. Residue is the observed y minus predicted y. So go back to our example. Observed y means original y. When x equal to 3, observed y is 5.2. So 5.2 is the observed y. Okay, 5.2 observed y minus predicted y. Predicted y is here, 4.75 predicted y. And the result is residue. Okay. Usually, we are going to use observed y is just y, predicted y is y hat. So y minus y hat is the residue. Residue, we sometimes use the epsilon or e. Okay. So that is the concept of residue. Now let's introduce the least square regression. Least square regression. Once we get the regression, again, we will make a prediction. Okay. Remember when we found a straight line, we can find many straight lines based on the scatter plot. For example, when you have this scatter plot, this line here we get from Excel, that is the best fit line. However, you can create other lines. For example, if you choose those 2 points, you have this straight line. If you choose these 2 points, you may get another straight line. So you can draw many straight lines, but there is one best. That best straight line is the least square regression line. This one here, the dot. And how do we produce the best fitted line? Okay, or least squares line. This is the topic we are going to talk now. Okay. So the equation for the least squares is given by, use this formula, you can produce the best straight line and make the best prediction. Okay, so this equation said, how do you figure out the slope? To figure out the slope, you use coefficient, linear correlation coefficient R, linear correlation coefficient R times standard deviation of y, SY is the standard deviation of y, divided by standard deviation of x. Okay, you get the slope. And how do you find the intercept, B0? You use average y minus slope B1 times average x, you get the intercept. You get the intercept. So now let's, so this is the best way to find the straight line. Okay, use these equations, not just select 2 points, not like this. Here we select 2 points, remember? This one you cannot produce the best fitted line. How do you produce the best fitted line? You have to use this method. This one here, y hat. Use y hat. All right. So now I'm going to use this example here, this x and y, to produce least squares regression line. We already used computer to produce this line. Now I'm going to use the formula to produce the same line. Okay. All right, so to use the formula, I need x bar, y bar, I need sx, I need sy. So I'm going to produce those values over here. So, oops. Okay, just have some water. You need the mean for x, the mean for y. You also need the standard deviation for x, standard deviation for y. So the mean for x is just the average. Maybe I want to increase the font size. You can see clearly, okay? So equal average. This is the mean for x, and the mean for y. This is the mean for y. Next, we figure out sx, sy, standard deviation for x. So equal stdev dot s. Dot s means sample. And the standard deviation for y, stdev. So I'm going to keep all 4 decimal places. So I'm going to copy this. Maybe I'll copy the whole thing here. Because I can make annotation, okay? So this 3.667 is x bar. This is x bar. This 3.933 is y bar. Y bar. And then 2.4221, that is sx, standard deviation for x. Okay, sx. 1.8239 sy. Okay, sy. Okay, because the formula needs those numbers. Those are back. And now, how do I calculate B1? I also need linear correlation coefficient R. So I'm going to use Excel to create R. Linear correlation coefficient R equal to COR REL correl This is a real one, x value, and then y value. So linear correlation coefficient equal to Control C. And then maybe here. Okay. So that is a negative 0.9476. So now I can calculate slope B1. Okay. Slope B1. B1 equal to R. Sorry, there's a bug. Slope B1 equal to R times multiply SY divided by SX. This is SY 1.8239 divided by SX 2.4221. Okay. So that is the slope. Negative 0.71. See, it is agree with here. Slope negative 0.7136. But we use formula to calculate it, this slope. Okay. And once you calculated this slope, let's figure out intercept B0. B0, see, based on this formula here, equal to y bar minus B1 times x bar. Okay, so equal to y bar 3.933 is y bar minus B1. This is B1 negative 0.713 times x bar 3.667 is x bar. Okay. So I got 6.55. Woohoo! It is agree with this one here. See, 6.55. Okay, 6.55. So we get just want to show formulas. Show formula. So I just want to show the, oops. Also copy the formula. So I'm going to make screen copy the screen so that you can see the formula. It is also copied my picture. I'll make the font bigger. So those are the Excel formula I typed in to get the linear regression equation. I need to calculate the slope B1. I need to calculate the intercept B0. Okay. And to calculate slope B1, I need linear correlation coefficient R. I need x bar SXSY. Okay. So that is the least squares regression line. Another name is the best fit line. Best fit line. Okay. So let's take a look at another example. This example is about the depth at which drilling begins. That is X. So X represents the depth. And Y represents time to drill 5 feet. The question asks you, using the drilling data, 1, found least square regression line. 2, predict the drilling time if drilling starts at 130 feet. Okay, predict. 3, is the observed drilling time at 350 above or below average? Okay. Question D, draw the least square regression line on the scatter plot of the data. Okay, so let's do question part A first. Go Excel, pull out the data. So this is the formula view. Where is the close formula view? Just try to, oops, my computer looks like frozen. Okay, let me see. Formulas. Show formulas. Stop calculator options. Okay, never mind. I can copy this data, Control C, and create a new worksheet. Control V. No, this is my screen copy. Go back to Control C. Control V. Okay. So I have this data. Okay, I have this data here. Question A, found the least square regression line. Found the least square regression line. So again, I need to calculate the average. And I need to calculate standard deviation. Okay, so I'm going to increase the font size. So the average for X is equal average. This is the average. And standard deviation for X, STDEV dot S. And do the same thing for Y. This time, I just use copy down the formula. And now I format the number to have 4 decimal places. 4 decimal places. So next, I'm going to calculate linear correlation coefficient R equal correl array 1, X is my array 1, comma, Y is my array 2. So that is my linear correlation coefficient R. And then I use this formula. I need to calculate B1 slope, B1 equal to R times SY divided by SX. Okay, so that is the slope. And then I need to calculate intercept, B0. B0 equal to Y bar minus B1 multiply X bar. Okay, that is the intercept. Once I have a slope, I have intercept, I can write down the equation, okay? So I'm just going to copy this data to OneNote so that I can make a notation. There's overlap here, okay, that's fine. All right, so I have B1, B0, okay? So the equation is Y hat equal to B1, see here, B1X plus B0. B1X plus B0. Okay. And equal B1, where is B1? 0.0115, 0.0115 x plus B1. B1 is 5.5272. 5.5272. Okay, so I answered the first question. Find the least squares regression line. The answer is here, Y hat here. Okay. Question B, predict the drilling time if drilling starts at 130 feet. So make prediction. You just plug in this X with 130. Okay, so I'm going to use Excel to do it. So predict. So when X equal to 130, what is Y? Y equal to B1, this is B1, times X, 130 is X, plus B0, 5.52. Okay. So that is the prediction. The result is 7.029. I have the result is 7 point. So the result is 7 point. You plug in 7.0292. Okay. So maybe so we finish question B, predict. Question C, is the observed drilling time at 130 feet above or below average? The observed drilling time is here. Look at this pair of data. Okay, this is observed data. When X equal to 130, observed Y is 6.93. 6.93. Our prediction is 7.0292. 7.0292. So our prediction is above the observed value because 7.0292 greater than 6.93. Okay, so we complete this part. Last question D, draw the least squares regression line on the scatter diagram. So there are two questions here. One, draw a scatter plot. Two, draw a straight line on the scatter plot. Okay, so let's go back to the Excel to draw a line. So select the data, including the label, and then insert scatter plot. Scatter plot. You have this scatter plot. Okay, you created scatter plot. Next, add a straight line by click Add Chart Element button. Select Trend Line and select Linear. See, you have straight line. If I ask you a further question, use Excel to produce linear regression. What do? You have this straight line. Under the format chart area, you double click this straight line, okay? And you click this button here, select display equation on chart here. Display equation on chart. Say you have this equation here. Okay, and I can make this equation bigger. See, this is the equation. Okay, so I just copy maybe this part, Control C to here, maybe over here. See, this is the equation, scatter plot, straight line, all in one. So we use the formula, created least square regression line. Next, let's interpret the slope and y-intercept. The interpretation of the slope. In this example, the slope is, see here, 0.0115 or 116 if you round up, okay. The slope is 0.0116. It means for additional foot of depth, we start drilling. The time to drill 5 foot increased by 0.0116 on average. Generally speaking, the interpretation of the slope is when you change x by 1 unit, how much change in y happened? That is the slope. Change x by 1 unit. Slope means how much unit has been changed for y. That is the interpretation of slope. And to the interpretation for y-intercept, okay, y-intercept. Before you make a interpretation for y-intercept, ask yourself 2 questions. Question 1, is 0 a reasonable value for explanatory variable? Remember, explanatory variable is also called x variable, this direction. Okay. If 0 is not a reasonable value, there is no need to make interpretation of the slope of the intercept. Okay. You make interpretation only when 0 is a reasonable value for explanatory variable. So question 2, do any observations near 0 exist in the data set? Okay. So in our example, we get intercept 5.5272. This is our intercept. How do you interpret this one? Okay. So a value of 0 is reasonable for the drilling data. This indicates that the drilling begins at the surface of Earth. The smallest observation in the data is x equal to 35 feet. See here, x equal to 35 feet, okay, which is reasonable close to 0. So interpretation of y-intercept is also reasonable. Okay, so how do we interpret this intercept? The time to drill 5 feet when we began drilling at the surface of Earth is 5.5273 minutes. Okay. All right. That's all for this video. In summary, what we did in this video. We did 3 things, okay? First, we found the least square regression line, okay? How do we find the least square regression line? You can use 2 methods. 1, use a formula. 2, you use Excel to get a straight line, okay? This is the first thing we did, found the least square regression line. And the second thing we did is interpret the slope and y-intercept. Okay, so this is the second thing we did. And the last thing we'll use maybe for next session, compute the sum of squared residues. We are going to do the diagnostics of least square regression in next section. Okay, all right. Thank you so much for your time. I look forward to see you next time. Bye.